The first segment of this video demonstrates paving techniques. We extend our thanks to Barber Green, Caterpillar, Cedar Rapids, and Blaw Knox for their generous help. Our particular thanks goes to John Irvine of Cedar Rapids, who nearly 2 years ago patiently led us through our first efforts in producing a paving training presentation. We've also worked with several asphalt contractors throughout the country in producing the paving sequence. Tyrone Hayes, the paving advisor of the Asphalt Contractor magazine editorial staff, provided much of the information shown. Tyrone has been a paving operator for nearly 20 years and has years of experience with all major brands of road paving machines. This is late season work, a parking lot. The kind of project that many contractors handle late in the year when the temperature dips below 40 degrees. Too cool and unpredictable to be doing much in the way of road work. At any rate, last night the contractor left this paver parked at the job site so he could get off to an early start this morning. And parking overnight at the site sometimes creates problems. This contractor eliminated one of them by lowering the screed to the ground before he left. No overnight visitor will accidentally lower the screed and crush somebody's foot. An unattended paver makes its owner liable for the antics of unwanted visitors. This paver doesn't have locking switch covers, so the operator will have to check all the switches to make sure nobody climbed aboard overnight and flipped something on. Machines are not supposed to start unless they are in neutral, but some of the older ones will. The paver might lurch forward, or the conveyor might kick on when the operator hits the starter. So he'll check all the switches before startup, all to make sure nobody gets hurt. He'll also check the hopper and conveyor to make sure there's no overnight accumulation of cans, rocks, or dirt that could contaminate the first load of paving material. Luckily, this paver has a locking fuel cap, so the contractor doesn't have to worry about overnight visitors pouring dirt into the fuel tank. The operator will check other things too before startup. He'll look around for hydraulic leaks. He'll check the rollers up front to make certain they're not stuck with asphalt and can roll easily. Now, assuming that the paver isn't sitting on dry grass where it can start a fire, the operator will light the screed burners. He seldom lets the burners run for more than 10 minutes. That's generally enough time to bring the screed up to about the same temperature as the asphalt. He'll shut the burners down for 10 minutes and then relight them if necessary. A hot screed keeps the mix from sticking to the screed plate and tearing the mat. If it's not hot, the screed will angle down when you start paving. Sometimes, though, you have to keep turning the burners off and on all day long, particularly when it's cold and windy, and you're picking the screed up off the asphalt and moving it around a lot, like on this parking lot project. If you leave the burners on too long, you're going to warp the screed, and you can't control a warped screed. It makes it nearly impossible to maintain a consistent depth. Before we move on to the job, however, let's take a look at paving machines in general. There are two basic units that make up a machine: the tractor and the screed. The tractor provides the power to pull the screed. The screed glides through the hot mix, distributing it and smoothing it. The tractor handles many jobs. It moves the paver, of course, and it pushes the trucks as they unload into the hopper. It also generates all the power to move mix back to the screed. The screed is towed by the tractor. It smooths, levels, and seals the mat surface in preparation for the roller. It also consolidates the mix to about 80% of its target density. The screed is attached to the tractor by side arms, which are attached to the tractor at toe points or pull points. From the toe point, the screed is free to float up and down, depending upon the amount of material flowing underneath it. This free-floating action minimizes the irregularities in the riding surface by filling in the low spots and skimming over high spots in the grade.
The screed is attached to the paver by these side arms here, and where it's attached here is called your toe point.
The mat thickness is determined by the height of the toe points and angle of the screed being pulled through the mat. Changing either the toe points or the screed angle will affect a change in the mat thickness. But first, the toe points on each side of the paving machine must be centered. Both toe points should be centered an equal distance top to bottom of the cylinder travel. Before you move the toe points, make certain that the hydraulic valves that feed the toe point rams are open. This permits hydraulic oil to flow to the cylinders so you can adjust pull point positions. Next, turn the power on at the master switch, which activates the automatic controls.
I'll come around to the back of the machine, and I have a control box here that has off, in motion, or constant. They'll be in different places in different machines. But this machine here has an on, off, or in motion. Now the in motion, it will only work when the machine is traveling, when it's moving. So when I stop, if somebody accidentally bumps my grade control sensor or something, it won't cause it fault in the mat. It doesn't work, in other words. But I'll flip it on constant now, which is power on all time. I come here to my grade control box, and I'll jog my arm up. I have this on manual back here, and then I can just jog that arm up to where it's in the center position.
After centering the toe points or pull points on both sides of the machine, you're ready to adjust the screed.
Now, I have to adjust my manual control.
Turn the hand wheel on one side of the screed until you find its neutral position, until it's loose and free. Then go to the other side of the screed and turn that hand wheel until you find its neutral position, again loose and free. Finally, go back to the first hand wheel and adjust it once again, because its neutral position may have shifted when you adjusted the other screw. After you've found the neutral positions on each hand wheel, turn each about a round and a quarter to tilt the screed up.
That raises and lowers the front of your screed level right here.
You will also need to adjust the crown in the screed before you start paving. The crown adjustment raises and lowers the center of the screed. The front and back may be adjusted separately or may be linked together to adjust in unison. Every paving job is likely to have a different crown setting. Often, while on road work, the crown on the front of the screed will be about 1/8 of an inch higher than the crown at the back of the screed.
This is the back side of the screed, and this is your front side, and it's chained together because it's preset at probably 1/8 of an inch higher in the front than it is the back, no matter what the set.
The crown may be up to 3 inches high on wide pavers on road work. However, the screed is seldom crowned in parking lot work.
If you're paving in a parking lot, you'll want to flatten this screed, because if you don't, you'll have a little higher in your center, and it'll come down, and then your next joint will go up and down, and you'll have a parking lot full of valleys and water holes. You don't want that.
If the screed is crowned too much on the leading edge, the front of the screed permits the flow of too much hot mix under the screed at its center. Consequently, too much mix is compacted at the center, leaving an unfinished texture on the outside edges of the mat. At the same time, too little crown on the leading edge will cause a greater flow at the edges of the mat, with greater compacting at the edges, leaving an open texture down the center of the mat. The screed is attached by side arms, which are attached to the tractor at toe points. From the toe point, the screed is free to float up and down, depending on the amount of material flowing under it. This free floating action minimizes the irregularities in the riding surface by filling in low spots and skimming over high spots in the grade. There are 4 ways to run your paving machine. First, you can run totally on manual. A screed man at each corner of the screed is sticking the mix and checking the slope with a level and operating the hand wheel or the remote toe point control to maintain the proper grade or slope. If you're going to start off in full manual using the hand wheels, you'll either pin both toe point cylinders or shut off their hydraulic oil flow so that the toe points won't drift. If you're going to use remote toe point controls, the cylinders should be left open for hydraulic flow and toe point movement.
If you're going to be running in the manual and not using your automatics on your paver, you turn your automatic switch back off, which you had to have it to center your arms. You've already got that done. You centered your screws, so you just start paving, and if you need to change your depth, while you'll turn your right side for your right side or the left screw to change your depth if corrections need to be made. And they will be the only adjustments you have run on the manual side.
Generally, a paving machine will have a right-hand screed man and a left-hand screed man. Each man is experienced in operating his side of the screed. It's his specialty, and he should be the only man to touch the depth crank or the remote toe point controls. If you have a screed man, workers and inspectors all sticking the mix and all turning the depth crank, you'll get overcompensation and a mat that's full of hills and valleys. Don't adjust the mat thickness on the basis of a single measurement. Stick in several times of the length of 20 to 30 feet before making a correction. Second, you can run on automatic grade only. Adjustments on the slope side are made manually, but you'll automatically run on a curb, string line, or skis on the grade side. By the way, if you're running on skis, make sure the rigid support is on the front. If you accidentally turn it around, the ski will swing up and create ripples in the mat. At any rate, your grade sensor will provide a base reading, and the controller will adjust the toe point on the grade side of the paver to compensate for irregularities on the road. It's important when using the automatic grade control that the sensitivity setting on your grade sensor is correct. If the system is too sensitive to small changes in grade, you'll get a constant up and down searching or hunting action at the pull point. Each paver is different, but in this case, the difference being between too sensitive and not being sensitive enough is only the difference in the thickness of a dime and a nickel. This grade sensor has been adjusted so it doesn't react to the width of a dime, but it does react to the width of a nickel, which is just about the right degree of sensitivity. The third option is running on automatic grade and slope.
Once you're running in automatic, your manual control shouldn't be touched. If you need to make adjustments, you have to do it with your automatic slope or grade control, and they change your point of attack of your screed by changing your toe point up on the front of your machine there. They raise and lower that cylinder that we centered a while ago.
If you're coming off a cold joint, the screed is probably already at the proper slope, assuming that it is an equal distance above the cold joint at both sides, and assuming that the cold joint has the proper slope. The existing mat should be straight-edged before setting the screed onto it to make sure it's correct. The screed should set fully on the cold joint, atop slats, laths, or blocks that represent about 25% of the thickness of the mat you're going to lay. That way, when the paver takes off, the mat will be about 25% thicker than the cold joint and will compact to the thickness of the cold joint when rolled. If you're placing a new lift, you can place blocks beneath the screed to generate the proper height. There are several ways to ensure that the slope is proper. The most basic is to check the screed slope with a level on the paver or to check the mat. When you've adjusted your slope to its proper percentage, then dial in that slope on the automatic slope control, and the system will automatically maintain the proper elevation on the grade and the slope sides. The system adjusts the pull points on both sides of the paver to a fixed elevation, even though the paver is traveling over an irregular base. Finally, the fourth option is dual grade controls. The machine is taking a grade reading on both sides and adjusting automatically. This is useful on super elevations when the slope changes from positive to reverse, and other applications where mat thickness is best related to the baseline reading.
Or if you wish, you can run manual for 20 or 30 feet, and if your thickness and your slope and everything is suitable, then you can flip your automatic boxes onto automatic, and it'll take over from there. If you want to take off in full automatic, which some screed operators like to do, after you center your arm, set your manual screws, just flip on your full automatic on your switches here, and if you need corrections in, you won't bother these manual screws because they won't work anymore. You'll have to make your adjustment with your automatic boxes, which you just turn up or down. basically the same as this, only it changes your pull point up front, up or down, which raises or lowers, changes your angle of attack here.
When the paver is running in automatic, the manual screws which control the angle of attack are not used. However, the angle of attack may change while the paver is running in automatic when the toe point rises or descends. You use the right and left-hand wheels to adjust the angle of attack of the screed only when you're running in manual. When the screed is tilted up, the mat thickens. When the screed is tilted down, the mat's thickness decreases. As the screed rises or falls, its angle levels off as the mat reaches a plane that is parallel to the direction of pull from the toe point. Since the angle of the screed is affected by the height of the toe points, if the toe points are set too high initially, the screed will continuously nose down in front. Running it at this angle creates abnormal wear on the leading edge. If the toe point is set too low initially, the screed plate will continuously nose up and wear out at the back edges. When you are adjusting the angle of attack of the screed, don't be impatient and attempt to correct the depth immediately. If you do, you'll be cranking up and down on the depth adjustment continuously, and you'll have an uneven mat. Changes begin to occur immediately, but the machine may travel forward several feet, depending upon the weight of the screed, before the change is completed. But let's assume that you're ready to go. You've chosen the paving mode and set all of the automatic or manual adjustments perfectly. Can anything go wrong? You bet. In fact, about 90% of all paving problems are directly related to maintaining a consistent volume of hot mix in front of and along the entire length of the screed. The volume of hot mix in front of the screed determines the amount of resistance to forward motion that is exerted on the screed. Properly fed, the volume of hot mix is almost level across the lateral length of the screed, and it almost covers the auger shaft. If this volume of hot mix, which is also known as the head of material, is too high or has buried the auger, resistance to forward motion will increase and the screed will rise. This will increase the mat depth. At the same time, because the material is boiling around the buried auger, it can be compacted before it flows under the screed. In fact, the action of the auger and compression created by forward movement of the screed may compact the material even more than the screed bottom. The result often is ripples in the mat and auger shadows. On the other hand, if the head of materials is too low, the pressure by the screed against forward motion is decreased and the screed will fall. This means reduced mat depth and possible tears in the mat. The head of materials should be level along the entire length of the screed at a depth that's almost over the shaft of the auger. Getting the head of material at the right height and properly distributed along the full length of the screed depends on, first, proper positioning of the flow gates, second, proper positioning of feeder switches, and third, proper speed setting of the auger conveyor system. First, let's talk about positioning of the flow gates. They should be positioned about half open when you start paving. Then you watch your augers and adjust the flow gates according to the mat depth and your forward speed.
So if you have your flow gates too high, why, they'll bring too much material in and your augers will shut off, and then it'll take them a period of time to turn on again, which will make them run less than the 80%, which causes shadowing and tearing of the mat and stuff. So you just select your travel speed to keep up with your trucks and your crew, and you adjust your flow gates up and down to where your augers are running at least 80% of the time.
And you'll have to watch carefully, because adjusting them is not necessarily the easiest part of the paving operator's job. In fact, it seems at times that the best position of the flow gates is backwards.
Say you're paving at a certain width, and you have to extend out maybe 3 or 4 foot wider than was a lane, like the end of a turn lane or whatever, or maybe an intersection you're trying to reach. If you extend your width and without putting any auger extensions on, you're going to find that you'll have to lower your gates to get that material pushed to the outside, because if you raise them too high, it'll all bunch up in the center and it'll get against carrier arms that holds outside of your augers and maybe even boil over the back of the screed, and they'll still be empty on the outside. So if this occurs, you should lower your gates down, and that'll push your mix out farther. Instead of raising them to get more material, it just works opposite of what it looks like it does. Sometimes when you're paving, you'll have to run these hydraulic extensions out here for just maybe a short time, or not like an all-day job. Because if he's going to be running all day, you'd want to put an extension on this auger here and run your augers on out here. But if you do run this out without your auger extensions, you're going to have to cut your gates down in the front, because you'll have a big head of material with your gates too high inside there, and it'll catch on this carrier bearing here, your augers, and it'll just all build up there, and you won't get no material out here at all. So even though you're laying wider and maybe using more mix, you'll have to cut your gates down, and a lower amount of mix will travel out to the outside of your gauge.
The next consideration is your automatic feeder control sensors and switches, or automatic paddle boxes. They control both your auger and the conveyor that feeds the auger. If the feeder wands, which are positioned at the tips of the auger, are positioned too high, the auger will overfill and the mix will compact in front of the screed. There are different kinds of material feed systems on pavers. The first utilizes an on-off limit switch.
Here is your automatic feeder control, and this particular one is just on or off. But you can raise and lower it. And it has a screw on the back that you just loosen, and then you raise this, or you lower it, whatever you want to do here. And as this kicks on and off, this turns your auger off and this turns it on. Well, a small amount of material will strike this because it's closer to the ground. If you want more mix, you just slide it way up there, and it'll take more material to reach it, which way out here would shut it off and shut it on. So really the only adjustment here is just your up and down, your height from the ground. It takes less material to reach here, and if you need more, you just raise it. You take a bigger head of asphalt before it gets to your switch to turn it off.
In this case, when material lifts the sensor to a certain height, it switches the system off, and the auger and conveyor both stop. However, until it stops, the auger and conveyor run continuously at one speed. Some pavers permit the operator to select a speed, high, low, or medium. When using this type paver, the feeder control setting and speed should be adjusted so that the auger is turning at least 80% of the time. 100% of the time is even better. Other pavers are equipped with an infinitely variable material flow speed control. These systems move mix according to the height of the sensor. The lower the arm falls, the faster the auger turns. The third factor which determines the success of a paving job is paving speed. Forward motion should be consistent. Every time you stop the paver, you're going to leave a screed mark in the mat. You'll get a depression when the screed sinks into the mat when it's stopped, and you'll get an increase in mat thickness while the paver is moving slowly during startup once more. And then finally, the mat will drop back to its original thickness as the paver gains forward speed. If all this sounds bad, it is. In fact, stopping the paver is the single largest cause of quality shortfalls in the paving business. To keep running without stops and starts, the paving speed must correspond with plant production, the availability of trucks, and the speed of the paving crew. The speed of your paving crew is your first consideration. If you outrun them, the whole job will slow to a crawl. If your rakers are patching holes and you're far ahead, they'll have to haul or carry material back to their work site. If you're too far ahead, the mat may have cooled by the time they reach it, and try as they may, they'll never get it to look right if the mix is cool when it's moved or raked. So first of all, keep an eye on your crew. If they're having problems, then slow down. Make certain your crew has a hot, fresh mat with plenty of material close by. And speaking of watching out for the crew, you'll need to watch out for a number of things at the job site too. If you're paving a tree-lined road, for instance, chances are sooner or later one of your trucks will catch an overhead limb when he dumps. Often enough, he can't get away from the limb by pulling forward, so you'll have to back the paver and tear up the mat to get him loose. It pays to have a good dump man, but even an experienced dump man can't see everything because of his position beside the paver. But let's get back to paving speed. Try not to outrun your trucks. If your plant is selling mix to other contractors or has several laydown crews at work in the area, your forward speed may be simply a matter of educated guesswork. But if you're the only paver being fed by a plant, then you can get very close to what your forward speed should be even before you start the job. It works like this. A square foot of hot mix, 1 inch deep, generally weighs 11 or 12 pounds. If you're paving 2 inches deep, then you're using 24 pounds of material per square foot. If your paving width is 10 feet wide, then you're laying 240 pounds of material with every foot that your paver moves forward. A 100-ton per hour hot mix asphalt plant will provide you with 200,000 pounds of hot mix per hour. A 200-ton per hour hot mix asphalt plant will provide you with 400,000 pounds of hot mix per hour. But let's keep this example simple. Say your paver is being fed 200,000 pounds of hot mix per hour with a 100-ton plant. You're using 240 pounds of hot mix per forward foot because you're paving 2 inches deep and 10 feet wide. To get your forward speed per hour, you divide the plant's hourly output by the number of pounds your paver is using per forward foot. In this case, 240 divided into 200,000 gives you 833.3 forward feet per hour, a little over 13.8 feet forward per minute. Paving 2 inches thick, you'd move at 13.8 feet per minute. Paving 1 inch thick, you'd move forward at 27.7 feet per minute. Of course, a job seldom moves this smoothly. We all know there are times when there are from 5 to 15 trucks ahead of the paver. It happens when you're putting in intersections, cul-de-sacs, and other slow projects. It happens when all the trucks get caught at a railway crossing or a wreck and pile up to descend upon you all at once. It happens when the paver breaks down. So you have to synchronize all the paver adjustments to handle the problems that routinely occur. Just remember, first, ideally, you never stop the paver on a hot mat. But next, it's usually more advisable to stop the paver on a hot mat than it is to outrun your crews. And third, you keep forward motion uniform. It's generally better to stop the paver than it is to slow it to a crawl in an attempt to conserve a little bit of mix you have left in the hopper when there's no trucks in sight. Remember, slowing the paver to a crawl can make the head of material rise in front of the screed, pre-compact the mix, thicken the mat, and make auger shadows, all unless you adjust the rate of flow through the conveyor and augers. And fourth, if you have to crank up paver speed to handle an influx of trucks, then tell your screed operator to watch the mat thickness. For if you increase your speed too much, the screed will go down. Still, another difficulty in changing paver speeds is that you're also changing the number of vibrations that your screed utilizes to compact the mat. Generally, the screed tamps and compacts the mat to about 80% of its target density. The mat immediately behind the screed has air voids, which represent about 15% of its volume. After it is compacted by rollers, air voids represent only from 2 to 5% of its volume. The problem is that the frequency of the screed's tamping doesn't change automatically to match the screed's forward speed. That means if the screed is moving fast and covering more square feet per minute, the tamps are spaced further apart. The mix is getting fewer tamps per square foot, and consequently, the mat has less compaction. So if you increase your travel speed, you need to increase your vibrator speed manually. Unless the forward speed of the paver is held constant, it's simply not possible to lay a mat of uniform depth and uniform density. Don't assume that just because you're using automatic grade and slope controls, that the paver will automatically compensate for differences in forward speed. It won't. It won't control compaction. It may not control depth adequately, and you may have to adjust your auto feeder switches. The way you handle your paver during the day is the difference between profit and loss, between quality paving and a botched up job. But the way you handle your paver at the end of the day is mighty important too.
I've run this hydraulic screed extension out here, and this channel here will accumulate asphalt through the day, and in the morning when it's cool, especially in the fall, if that's all full asphalt, when you suck that in at the end of the day, it'll stick on you and you can't get it out. And maybe first thing next morning you need to run it out like a foot or so, and sometimes you have trouble. So you always clean all that out and spray it down with diesel good. And also you pick your screed here up off of the ground and you spray diesel underneath it, because it'll start off easier in the morning, and it just works better all around. Also, these side arms, like on up here you can see, accumulate asphalt. You just take a scraper and just knock it off, and along the back of your screed, and just keep the excess material off, because it just a little bit each day keeps accumulating. The first thing, maybe you have to work on it or something, and all that's got cold on you and it's hard to get off, and it's easy just to knock it off each evening and spray a little diesel on it. And my augers runs through here. I always spray them with diesel, and usually the catwalk gets a little light spray because the guys track prime and asphalt up on it. So in general, you just kind of knock the loose mix off, and your feeder switches, they build up material through the day, and you have to clean those and spray them down with diesel. These chains here are your drive chains for your augers, and you have to watch. A lot of times asphalt, maybe a truck's spilled in front of you or something, and you get asphalt in these chains, and it doesn't hurt to spray a little diesel on those and not let them get dry. And then your automatic auger feeder switch here, see how there's material accumulated here now? Well, this will build up, and this paddle won't work. It'll just get hung up. So you have to clean that off and spray that down every evening. In fact, I usually do it 2 or 3 times a day. And then I'll come around to the front of the machine here. Now this has been sprayed a little bit, but see, we got a lot of excess material here, and I'll just take a scraper and knock that in. And then these rollers needs to be sprayed, and so they'll turn freely in the morning. And then I'll take my spray and I'll hold it down in here on this conveyor chain, these flight chains here. On each side of these flights here accumulate asphalt through the day, and it's very important that you just hold your spray in this one place with them turned on until they make a complete circle, and then do this side, and then you do your other conveyor the same way, because the mix gets cold through the night, and maybe you've got 4 or 5 trucks waiting first thing in the morning. You get ready to go and your conveyors won't turn on, and they're stuck. And you also need to grease either of the morning or the evening. If you have time, the evening is really better, because all your bearings are hot, and they'll take the grease better.
Coming up next, rolling and compacting. Asphalt contractors throughout the U.S. are now seeing compaction requirements become more difficult. Many states are specifying higher stability mixes, larger aggregate with 3 to 5% voids in the mat. And in many cases, because of high stability mix requirements, it takes far more compactive effort to cover the same area than it did just 2 years ago. Consequently, a compactor or roller operator's job now requires a more expert approach. Compaction needs to be carefully pre-planned for the greatest result. And all pre-planning starts with the presumption that the compaction equipment is in good working order. Among other things, that means a daily checkup before startup. We realize that compactor maintenance requirements vary a lot. So we've chosen just those maintenance requirements that apply to nearly any roller, static or vibratory. The next issue of this series will cover maintenance of pneumatic compactors. Helping us is Bob Copes, District Service Representative of the Heister Company. Our thanks to the Van Keppel Equipment Company of Kansas City, Kansas, for providing the facility and equipment for this demonstration. Now, on to the roller maintenance portion of this program. Bob, you see, is lifting the shroud on the engine and is starting some of the checks right now.
To start up the engine, you check the engine oil, so lubrication for the engine. Check the condition of the oil. It's nice and clean on this dipstick and it's at the full mark. Check our engine coolant. Look down in there, we have a nice green liquid. It's covering the top of the internal core of the radiator. Check the fan belt tension, make sure that I don't have a loose belt. Check the belt visually, make sure that it's not cracked, it's not glazed, indicating slippage. Look at the fan, make sure that I have no contact at the fan tips. The fan and the shroud, there's adequate clearance all the way around the fan, nothing bent, nothing chipped. I will look for any fuel leaks, oil leaks that are present or evident from the top of the engine. Air cleaner intake line between the air cleaner and the intake manifold. No apparent cracks, kinks, buckles. There generally on a roller will be an air intake indicator that indicates a clogged air filter. The hoses are in solid condition, both the upper and the lower radiator hose. No evidence of leaks. Be sure that the bail lock is fully engaged anytime that you get off of the roller so that there is no inadvertent movement of the bail control, the forward reverse control. Brake switch should always be put in the on position whenever stopping the roller and whenever leaving the roller. Most rollers will have a battery condition indicator or a charging condition indicator indicating that the alternator is putting charge to the battery. Engine water temperature is important that it be monitored every few minutes to make sure that we do not overheat the engine. Engine oil pressure should always be present whenever the engine is running. From a cold start in the morning, it may take a period of 2 to 3 seconds before you will see pressure on this gauge. If you do not see pressure within several seconds after starting the engine, shut it down. It indicates that there's a internal lubrication problem. Fuel level is picked up in the fuel tank, indicating the amount of remaining fuel. There's transmission oil temp on a hydrostatically driven roller. The hydraulic oil temperature is read on this transmission oil temperature. It should stay in the operating range roughly of 180 degrees. And of course, an hour meter indicating the need for the periodic service intervals for the engine oil, filters, and other maintenance areas on the roller. When starting the roller, it's important to check that the brake system is in operation. And with the brake switch on, unlocking the valve, make sure that the brake has the ability to hold the machine when placed in a forward or reverse travel position. In order to clean or remove debris from the oil cooler and the radiator, the air, compressed air, or steam used should be done opposite the flow of air, the normal flow of air through the oil cooler and the radiator. So that cleaning would take place from the inside, blowing the debris out rather than further lodging the debris into the oil cooler and or the radiator. The roller should have an operational horn. While steering the machine, check the joint where the steer cylinder attaches to the frame and to the guide roll, making sure that there is no loose condition here. In order to safely come off the machine, 3-point stance should be used. 2 handholds, one for each hand, and one for the foot, and down onto the ground, rather than jumping off of the roller. Water entering the water spray system should first go through the water strainer to strain out any chunks that may be in your source of supply of water. Further, on some rollers, there may be an additional strainer down inside of the tank in the form of a filter and or strainer. The type of water to be used in a water spray system preferably would be hydrant water. That is not always possible. Sometimes you have to borrow water from ponds. Any water put into a water spray system does have the potential to grow algae inside of the tank. A good preventative for that algae is the periodic use of chlorine. Either liquid chlorine is in laundry bleach or through your local swimming pool supplier, chlorine tablets. The oil cooler and the radiator should be checked from this angle to make sure that there is no debris obstructing the flow of air through the cooler and the radiator. I want to look underneath the roller and make sure that we have no oil drips. No oil has been leaking overnight underneath my roller, either engine oil or hydraulic oil. No other types of leaks, water leaks. The water seen here on the floor is because we have the drain plugs of the water tank removed. In colder periods of time, you want to drain the water tank down every night and perhaps introduce a little antifreeze into your water spray system so that the following morning you're ready for a good clean startup. You don't have to defrost your water spray system. Otherwise, we have no evidence of any oil leakage, hydraulic or engine oil or antifreeze leakage underneath this roller. All the hoses need to be checked to make sure that they are not kinked, they are not rubbing against an area, no holes or wear spots. All the connections are tight and dry, no oil. Also an area of vandalism here. Vandals have a tendency to cut any wire or any hose that might be exposed. All rollers are equipped with a fail-safe braking system. This particular roller uses a spring-applied hydraulically released brake. Brake operation should be checked upon startup each and every morning. Start the engine, but do not release the brake. Run the transmission both forward and reverse against the brake, making sure that the brake has the ability to hold the machine in a stopped condition. After filling the water tank with water, the operation of the water spray system should be checked. Turn your water spray system on, make sure that you have a very good flow of water, a nice spray pattern coming from each of the spray nozzles. If not, that is the time to remove the nozzle and remove any debris that may be plugging the nozzle up. It's also a good time to check the cocoa mat. Rubbing against the drum, make sure that there is no debris trapped into the cocoa mat, that the cocoa mat is relatively clean and in good contact and has a lot of wear area left to it. The rollers will have either a direct drive hydraulic motor or a hydraulic motor combined with a gear type final drive. There is a supply of oil to the hydraulic motor, and those lines need to be checked to make sure that they are tight. No leaks, they're nice and dry, no oil comes up on your hands, no kinks and no wear spots. Prior to startup, it's important to check the hydraulic oil level. Generally would be a sight glass on the hydraulic tank indicating that the hydraulic oil is at the proper level for operation. There will be a hydraulic oil filter. The filter should not have any dents, should be intact, should be dry, no leaks. This particular roller has a remote engine oil filter. That filter is dry, not dented, and secure. Again, checking the scraper to make sure that you have good contact across the full width of the drum. Might release any debris that may be caught in there. And then make sure you have an adequate amount of wear surface left. And then whenever rotating the machine, again, the scraper has the ability to be locked up and away to avoid unnecessary wear and tear. The guide roll on these rollers will oscillate as well as turn or articulate. There is a shaft and a set of bearings for the oscillation and for the articulation. When operating the roller, this is when you will want to check these pivot points to make sure that the bearings are not loose and that it's not indeed time to perform some maintenance. Look for looseness in the area of the joint between the kingpin and the steering trunnion. Also look for movement where the kingpin goes up into the frame. Any looseness noted in those areas should require maintenance. The scraper bar will wear into the split between the guide drums. This area requires periodic maintenance, perhaps in the form of a flat file, to knock the wear area down. Should the gap between the guide rolls become excessive and or the point which is worn on the scraper bar become excessive, a V will wear into the drum, eventually forming nearly a U shape down into the material, therefore marking the mat. So again, daily observation should be made of this area to not let the gap get excessively wide, and also maintaining the object which will grow onto the scraper bar.
Thanks for the maintenance tips, Bob. Now let's get back to the job itself. In a three-stage compaction process, the initial breakdown stage, the compaction stage, and the finish stage, as many as 3 different kinds of compaction machines are used: vibratory drum rollers, pneumatic compactors, and static drum rollers. Vibratory drum rollers and pneumatic rollers are generally used for the first stage of the compaction process, breakdown rolling. Often the breakdown rolling and compaction rolling stages are combined, using a vibratory drum roller or pneumatic compactor for both stages. A static roller is often used for both the breakdown and compaction processes. However, it may not be effective in compacting a high stability mix in thicker lifts. Use of rollers and compactors for each stage varies from state to state and from contractor to contractor. So, Bob, what does your ideal compaction train look like?
Should we take 10 people in the same room, we'll come up with 10 different opinions. I happen to believe that the ideal rolling train for asphalt compaction consists of the primary breakdown roller being a double drum vibratory roller, followed then by a pneumatic or rubber-tired roller, then followed by the steel wheel or static roller.
Why do you recommend a vibratory roller instead of a pneumatic compactor during the breakdown phase?
Should the rubber tire roller be placed first, you would have some fairly significant tire rutting that, yes, indeed, could be brought out by the double drum following the rubber tire. But you also get the emulsion or the asphaltic cement content being brought to the surface in such a large degree due to the deep penetration of the tires that it would have a tendency to cause an oversealing of the surface. Therefore, by setting up the initial compaction, the greatest amount of compaction being done by the double drum as the breakdown roller, you then get the manipulation effect just as efficiently with the rubber tire being behind the double drum vibratory, but yet you do not get the same pull of the asphalt material being brought to the surface.
You're saying that the pneumatic compactor belongs second in the compaction train. Where else is it most effective?
On a road that is rutted, the rubber tire roller is the roller that's going to achieve the uniform compaction. It will work the material down into the ruts without over displacing the material that is left on the high spot of the rut. Then your finish roller comes in along behind the rubber tire roller, leaving you a nice smooth mat. But the rubber tire roller is the key to the uniform compaction on a road that has been rutted.
One of the biggest problems at the laydown site is handling the longitudinal joint. Most techs recommend working from the cold side of the joint with a static roller, overlapping the joint about 6 inches on the first pass, and then working on across. You often see it done different. How's that?
I prefer to see the breakdown roller staying off of that longitudinal joint as they travel towards the paver by 4 to 6 inches, therefore setting up a wedge of material, a wedge of hot material against the cold joint. On the pass back out away from the paver, then you would straddle this wedge of material with the double drum vibratory, therefore pinching the seal down and virtually eliminating the seam of that joint. It will virtually disappear. Now, fracture of material is a major concern in the pinching of this joint. You have to leave an adequate amount of material to support the force of the double drum vibratory machine. That is something that has to be experimented with as the asphalt application varies. 4 inches, 6 inches, 8 inches, somewhere there is an adequate amount, an adequate distance to stay away from the longitudinal joint, setting up the wedge so that you do not fracture the material, but yet get a very, very adequate amount of compaction as you make your pass back out away from the paver and pinch down that joint.
We're seeing states go to larger aggregate mixes in order to improve stability, all of which makes it tougher for the contractor to get specification densities. What's your odds of hitting the right density without a nuke?
Nuclear densiometers are probably one of the most necessary tools that a contractor can have on a job. The nuclear densiometer gives the contractor the ability to set up a rolling pattern that will be ideal. Not too many passes, not too few passes, therefore maximizing the productivity of his paving crew. Once a rolling pattern has been established, the travel speed of the paver can be determined, and given that the contractor has the hull capability to haul the material to the paver, optimum and maximum working speeds can be determined.
And what happens then, Bob, if you just give the mat a few extra passes to be sure?
There is a curve that is attained when compacting asphalt. As too many passes are made over the material, the terminology is going over the hump. As we approach the ideal or laboratory compactability of the material, you can actually go over that curve and begin to break your material apart by over-compacting. Therefore, once you've gone over the hump, there is very little that can be done to bring that level of compaction back up to the target.
I suppose you could call going over the hump a relatively common mistake. Others that come to mind include outrunning the roller's vibration capacity. What happens then?
Yes, with a double drum vibratory machine, the faster the machine is run, the less efficient the vibrator actually becomes. As the impact spaces, due to the travel speed of the roller, become further apart, the vibrator actually becomes a less efficient machine. Therefore, a match must be made between the vibratory speed of the roller, be it 2400 to 3000 VPM, and the travel speed of the roller given in miles per hour, feet per minute, whatever. Ideally, we like to see a 1.2 inches per impact spacing. That can be attained with a roller that will vibrate at 3,000 vibrations per minute, traveling at 300 feet per minute, will give you 10 impacts per foot, 1.2 inches per impact. As that impact spacing increases, more pads will be required in order to get the same amount of compaction.
But what are the most common and costly mistakes?
Stopping the roller on the mat. Okay. An inexperienced operator will have a tendency to want to bring a roller to a stop, parked standstill, directly in the direction of travel. This will cause depressions in a hot mat that are virtually impossible to work out. The repair for that would be to shovel out the material and lay new material in. Whereas if the roller is stopped by turning at virtually a 45-degree angle across the mat, the depressions can be worked out with successive rolling passes across the area where the roller has been stopped. Therefore, the depression is not left in such a manner that the drum will fall directly into the depression left by the stopped roller, yet it will roll across, moving the warm material into the depression left and making a nice smooth spot again where that roller has been stopped.
We've already mentioned states are choosing larger aggregate mixes to improve stability. But with the oil shortage, there's rumbling of agencies specifying lesser quantities of liquid asphalt in the mix to save tax dollars. What's your reaction to that?
We're going to see a real nightmare if the price of oil stays up this year, because when the price of oil is up, the price of the asphalt is up also. So what does the state and the federal government want to do? They want to drop more asphalt out of that mix, so your liquid going in as a percentage of total weight will go down when petroleum prices are high. That gives you a lot of rock and very little asphalt to make the rock try to stick together, and the achievement of compaction becomes that much more difficult. You got to pound and pound and pound on the mix, and thereby run the risk of fracturing your aggregate in order to get the desired compaction. So now you have fractured edges of rock with no asphalt coating them. That is not a pavement that will survive a very long life. Well, they try to save money by dropping the AC content down, and I don't understand how anybody can save money by putting a road down today that's not going to last for years and years to come. When you've got to go back 2 years, 5 years later and resurface that roadway because we saved on 0.5% of asphalt in today's mix, that's not saving the taxpayers any money at all.
Coming up is a special sequence on rolling patterns and longitudinal joints. Our thanks go to Bill Steinberg of Ham Compactors for his help in the production of the following sequence, along with Joe McLaughlin of Superior Asphalt in Kansas City. Joe is a member of the Asphalt Contractor Magazine editorial board and a member of the Asphalt Video Advisory Council.
In this segment, we'll look at various rolling patterns necessary to get the smoothness and compaction necessary to meet project specifications. On most of our jobs, we use this little box here. This naturally is a nuclear density gauge. In this particular case, it's a Troxler 4640B thin lift density gauge. We'll measure between 1 and 4 inches of pavement surface, and is very helpful in helping to establish and define our rolling patterns. Once we have established a rolling pattern, some of the techniques that we'll talk about are also necessary to bring the pavement to a smoothness specification that can be tested with a profilograph or a straight edge. The roller operator is one of the most important members of the paving team. Regardless of what the paving train has done up to that point, he's got to take the mix as he gets it and make it meet compaction and smoothness specifications. He might get mixed that's a little bit too cold, he might get a mix that's a little bit too hot. He has to know the difference, he has to know how quickly to get on it, he has to know when it's time to hold back. If he sees he's got a major problem, he has to contact the superintendent immediately, let him know that they've got a problem, they've got to change something in their operations. Many times it's the superintendent then needs to get hold of the asphalt plant and have them make some modifications to get it there at a warmer temperature, or maybe it's too hot and they're not having time to cool it out. It's the roller man's responsibility to take the mix and to produce a rolling pattern that will give him the compaction and smoothness he needs to meet specifications. Each job needs to start with a specific rolling pattern. Each mix is different. Each mix requires a different type of rolling pattern. The rolling pattern can depend on a lot of different things. It can depend on the temperatures, it can depend on the type of mix, whether it's a surface mix, whether it's a base mix, how thick it is, how hot it is, how cool it is, the percent of compaction required. The rolling pattern is custom made for every job. The rolling pattern may change. It may change from when you started in the morning, it was cooler, and after lunch, it may be quite a bit warmer, and you're going to need a different rolling pattern. Most of the time, we try to establish a rolling pattern with our nuclear density gauge. We check after the breakdown roller, after the intermediate rollers, and after the finished roller. When we find that we're achieving density with a given rolling pattern, we stay with it. If things start to change, we start checking again. It may be that we need to move the rollers closer to the paving train, or maybe we need to back them off. We might need to make more passes, or we might need to make less.
The pattern is affected by the width of the road, the depth of the lift, whether or not the road has a crown, an unsupported edge, a longitudinal joint, and even the slope of the road. It's affected by the size and type of aggregate in the mix, the heat of the mix, and by ambient conditions that exist at the job site. The experienced job superintendent, or lead man, can often take all the factors into consideration and make a good guess as to the proper rolling pattern. The pattern may also be established by the specifying agency. After starting with a rolling pattern, only a nuke or a core test can tell whether or not the pattern is correct, whether or not it meets compaction specifications. The roller pattern is dedicated toward compacting the lift evenly to compact the lift to specifications throughout. Too often, however, the center of the pavement gets much more compaction than the outside edges. Inexperienced roller operators are inclined toward making multiple passes at the center line and single passes at the far outside. Actually, since the wheel path areas of the finished pavement tend to get greater traffic use, the sides of the pavement have the greatest need for specification density. Let's get back to establishing the rolling pattern. The width of the lift is the first factor that you have to work with. If the lift is 12 feet wide and your roller covers 5 feet in each pass, then you know that you'll have to make at least 3 passes to cover the width of the mat. You'll always need to overlap your last pass at least 6 inches to prevent creating a ridge. But in this case, a 5-foot roller on a 12-foot wide mat gives you plenty of overlap on each pass. Let's assume you're on a vibratory roller on a breakdown pattern and the lift is 4 inches thick. You're operating the roller at 3,400 vibrations per minute, and experience has taught you that you'll need 4 passes in each lane to achieve compaction that meets specs. Here are some of the factors you've had to take under consideration. First, there's the heat of the mix. You get maximum effect from the roller if you complete your pattern before the mix cools to 175 degrees. The breakdown roller needs to get on the mat as close as possible to the paver so it gets maximum effect from each pass. Generally, that means the breakdown roller is on the mat while it's still at 250 to 300 degrees. If the mix is hotter than that, the roller is creating waves and pushing the mix. However, rolling the mix while it's too hot isn't the only reason it'll push instead of compact. A mix designed with high voids will shove, as will a mix with too little or too much liquid asphalt contact, as will a mix with round or smooth-faced aggregate. But the width of the road and the character and temperature of the mix are only 2 considerations. Let's assume that there's an unsupported edge at the outside of the lift, and at the same time, let's also assume that on the right there's a 4-inch lift that was placed yesterday. That means a longitudinal joint you'll have to compact. Both of these factors, the unsupported edge and the longitudinal joint, also figure into establishing your roller pattern. The unsupported edge on the lift means your first pass may have to be back about 12 inches inside the edge. It all depends on the viscosity of the mix that you're compacting. But if it's a regular dense graded mix at a normal compaction temperature, an extra pass inside the edge will probably be necessary. A thick, dense graded mix at a normal compaction temperature will squeeze out beneath the roller like toothpaste in a tube, and you'll have a pavement that is a few inches too wide, with a depression and a hump along the edge. So your first pass has to be about 12 inches in from the edge to prevent squeezing the hot mix past the unsupported edge of the lift. Consequently, you must add at least 1 extra pass to the pattern to compensate. Now there's also a longitudinal joint on the right that will require pre-planning. How will you finish out the joint? The way you finish it determines how many passes in your rolling pattern. If you finish the joint in the traditional way, with the vibratory roller extending only 6 inches onto the cold half, or with a static roller extending only 6 inches or so onto the hot side, then it may be unnecessary to add an extra pass. But if you plan to squeeze the asphalt toward the joint, ensuring best compaction, and then roll the hump with the vibratory roller barely overlapping the cold side, you'll need to add an additional pass. And then if the road has a crown, your rolling pattern must also compensate for that. You'll need to roll on both sides of the crown from the downside up to avoid flattening the crown. So here's a road 12 feet wide. 3 passes with a 5-foot roller will easily cover at one time and give you plenty of overlap. And for the sake of simplicity, we'll assume that the edge on the left is supported, so no extra pass is required. And we'll also assume that you're going to finish off the longitudinal joint in a traditional manner. Consequently, there's no extra pass required for this operation. First, 1 pass means pass over the hot mix in one direction, not back and forth, just one way only. and that first trip up the hot mat toward the paver is made with the powered drum toward the paver. The powered roller pulls the mix back under instead of shoving it away and creating a wave in the asphalt ahead of the roller. While you're on the hot mat, you'll need to follow some basic operational procedures. If you're on a vibratory roller, you'll need to maintain a speed that's comparable to walking. It's necessary to match the forward speed of the vibratory roller with its vibrations per minute. Ideally, the spaces between the vibratory impacts on the mat should be about 1.2 inches or about 10 impacts per foot. For instance, a vibratory roller set at 3,000 impacts per minute, traveling at 300 feet per minute, will give 10 impacts per foot and about 1.2 inches between impacts. If you increase the distance between impacts by traveling faster, you'll have to make more passes to get the same amount of compaction. Then two impacts spaced further apart create a bumpy ride for traffic. Next, and here again this refers only to a vibratory roller, if you're nearing the end of a pass, you must turn off the vibrator before coming to a stop. Many rollers will turn off the vibrator automatically, but if yours doesn't, then you must, or you will vibrate a trough into the mat as your roller stops. Whatever kind of roller you're operating, all stops and starts on the hot mat must be gradual to prevent pushing ridges and troughs into the mat. Third, and this also refers to all rollers, each lane in the roller pattern should end at the same distance from the paver as it continues forward. This not only maintains an equal distance from the paver throughout the rolling pattern, but most important, it prevents a depression forming all the way across the mat where all lanes end. This makes a trough that can be extremely difficult to remove. You should be rolling as close as possible to the paver without causing the mat to shove or ridge. But at the same time, you have to work as far back from the paver as required to let the hot mix cool so it can be compacted properly. You're looking for specification density and smoothness with the fewest passes. Fourth, remember to turn the roller slightly at the end of each pass so that the ridge created when the roller stops will not be at an angle parallel to the front of the roller. This angled stop greatly simplifies removal of the ridge created when stopping the roller. And finally, when the pattern is complete and there's no more mat to compact, then put the roller on the cold pavement and stop. Don't keep running a pattern past the number of passes required to reach specification density. If you make unnecessary extra passes, the mat will decompact and lose density. And at that point, there's no way to bring it back to the required specs. We mentioned earlier how the temperature of the mix can affect the breakdown rolling pattern, but finish rolling is temperature critical too. The mat has to be hot enough to permit working out the marks left by breakdown or intermediate rolling. Yet if the mat's too hot, the finish roller will continue to leave marks.
As you've probably seen in this video, although there are some basic concepts and procedures that need to be followed, there's no set rolling pattern to establish a compaction for your given mix. You need to take the time to plan it ahead of time, to use whatever means and instruments are available to you to determine that you are getting satisfactory compaction and smoothness. The best rolling pattern is the one that will give you specification density and smoothness with the least amount of passes.